Okay, so a very, very quick refresher on the solids contact ideologies between a cone and a sphere. All right, so the first one here, I'm going to say that I want to draw in a sphere in contact with this cone. All right, so the cone is given the elevation in the plan. I want it to have a radius of 25 millimeters and I want it to sit on the 60-degree line. So where do I start off? Okay, the information I have, it sits on that 60-degree line. That's great. I also have that it has a radius of 25 and I know it's going to be in contact at this point. So first thing you can do, right, because you don't really know much at the moment, is measure up your 25 millimeters. Measure up your 25 and do a horizontal height across for that. Okay. So I have this here. To find where the center point is, I'll need two bits of information. I need two lines that go through the center point to get me a point. Right, so where two lines cross is a point. How am I going to do that? There's two ways you could do that. All right, with this question. First of all, is if you measured out 25 millimeters perpendicular to the edge here. Okay, you would get a line that's 25 millimeters out and will cross. The other option that's just as easy is that you could go bisect this angle here. And where that bisection crosses is the second line, and there's our center point. Now, a couple of things you need to note on this. When I've gone to draw this, I've gone and I've drawn this on the side. You might be thinking, well, no, miss, you told us it has to be on this line. It does. What we're doing is we're using a thing called generators. So every line that comes from the apex, which is this point here, to the base of a cone, is a generator. So there's one line here, right? That line is technically the same length as if I was to draw the 60-degree line coming down here. So if I was to draw that up in my elevation, all right, what would that look like? So that's where it touches the ground, bring that up. And if I just have this line here. So this line here, excuse me, and this line here are the same line. What you don't have with that though is you don't have a true length. And what we mean by true length is that you can't see the actual shape or the actual length of that line. The way I showed this to somebody earlier is, and it's really easy when you're on the camera, if I show you that pencil there, that pencil is 16.5 centimeters long. Okay? Now, what happens when I turn the pencil a little bit away from you? I can still keep it at the 0 point. Next thing, it's only 11 centimeters long. Now, that's a trick of the eye. You know full well that pencil is actually the 16. But what you're looking at is you're looking perpendicularly at that pencil so you can see the true length. And that's what you need to do over here. So you know that this distance here isn't a true length, but because it's a cone, if you were to look at this length here, so this line, looking straight in, that line is actually true length. It's the same length as this generatrix here. So that's why I'm able to draw this off the side. So what we're going to do is we're going to draw up our sphere in contact at the side, find the point of contact, find where it is. We'll bring it down and rotate it then to where it's actually meant to be. And we'll be able to bring up all of our information to where it's meant to be in the elevation then. Okay. If that didn't make too much sense, it's fine. Just follow through and pay attention to what I'm doing. Maybe watch this 1 or 2 times over. Okay. So what I have here now is I have a center point for a circle or a sphere that has a radius 25. I also need my point of contact. How you find your point of contact is get your set squares like this. Set it up so that edge is parallel and perpendicular from that center point. Now, that there, this point here, is the POC, point of contact. That's very important to label that in. Okay. Right, once we have that, that is the true length or the true size of our sphere. So we can measure this distance here with our compass. And we can draw in our sphere like that. Now, if you've done this right, it should touch the ground line and it should touch the side. Also, this is a construction because remember, this needs to move or rotate. So how we're going to rotate that down is we're going to bring the center point down to here. We're going to get our compass, open it out, and rotate that around. Now, just like that. So I now have this point here. That's the center point in its new place. So I could draw in my sphere in its new house down here. And I can do this one in heavy. Okay. Now, one or two things you need to pay attention to here. The end of the cone becomes hidden detail because it's under the sphere. So you can see the sphere is sitting over the base of it here. It's going to be the same when you bring the sphere up. So that becomes hidden detail. The other thing you need to make sure of is you need to bring down your point of contact and show where it is in the plan. And then you need to show where it actually is in the elevation. I'll show you how to do that now. So same thing you did to bring a point down to that line. You go straight down to here, because this is the line we were using to measure everything off of. You grab your compass. You go to that distance. And you can swing that down and around. Now, there. That's the point of contact. Okay, very important. And how you find that up here. So there's two ways you could find that. Okay. You could either bring this straight up and bring a line across from that point of contact and find where they meet. Or I've already kind of half drawn it in here. What you can do is you can join from the center down to the base here for your 60-degree line. You could draw that line in your elevation like I have here. And then all you need to do to find out where your point of contact is bring your point of contact up. You know it's going to hit on that line. And right there is your point of contact. Okay, so you can see I'm doing these a little bit bolder on these because this is the actual point of contact. That's construction. Right. Now, the last thing you need to do to finish this question is you need to bring the center of the circle up to where it's actually meant to be. Now, it's moved over, but the height of it hasn't changed. So when I bring this line up, it'll still hit the same height line. And that's where my center is going to be. So there. Put it out. And draw in your sphere where it's meant to be. And this one, remember, is the heavy one. So this is the one that's actually being kept. And if you look at your plan down here, you'll see that the sphere is in front of the cone. But this one is in front also, which means, again, you can grab your your pencil, and you can just do your hidden detail down along the side here. Just to show that you know that your sphere is in front. Okay, now you see I'm using a pen here just for the sake of the camera. You'll do that in pencil. So you put in your heavier detail there with your pencil just to show off that you know there's hidden detail there. Okay, so X and Y. Right, so that's the first one done. Nice and easy, I thought. Probably issues with no problems, just let me know. Okay. This one here is if we want to have a sphere that has this point of contact. Now, I haven't given you any other information. It's in contact at point P. Now, the thing with spheres is that if it's in contact at point P, there's only really one size it can be. So, what we're going to do is we're going to draw this line across here. Okay. what we're going to do is we're going to do the same thing we did earlier, and we're going to bring that line up and find out where it actually is. Okay, on the drawing here. So that is the line that holds the point of contact. Okay. I can also bring my point of contact straight up to this point here. Okay. So I have my point up here. I have my point down there. So what can I do? Well, if you look over this drawing, you know that if you bring the point of contact out to the edge and you go perpendicular, you'll get one of the lines that goes through the center point. So horizontally through there. Okay. You get one of the lines that goes through that center point. Okay. So set up your side and set squares to the outer edge now, remember, and go perpendicular from there. Now, what other lines do we use to build the one over here? If you have a look, I said to you, you could measure out the distance of the radius parallel to find the center. We don't have that. What we can do, because it's not numerically refined, is we can bisect the angle here and find that line. And where those two lines cross, so the point of contact and this line cross, will give us the center point of our sphere. Now again, in the construction zone. Right, so across here, here, there's our bisection. Straight up through there, and that gives us this point. So that's actually our center point. And we now have the radius here of a circle that's in contact at that point. But that's not the right place for it. It needs to touch this point in here, and we also need to draw down our elevation. So you're going to do exactly the same thing as you did over here. You're going to bring it down to this line. You're going to rotate it around until it hits the line it sits on, and you can draw it in then. So I'm going to extend my point P here. Okay. Going to bring my center down. Now, pay attention. That would not be right. And that's where a lot of you are going to make a mistake. What is right is that you are taking this section here. So there's that one out. And you need to rotate that back to its new house. So you can see, if you had taken this point here, you'd be well off. Okay. Now then, we have this and this. We have our new location for our center. We can draw in our sphere where it's actually meant to be. Okay, and what I can also do is I can bring the height of the center across, and I can find the real location of my center down here and bring it up. From there then, I can draw my sphere heavy. Okay, so you can see with this kind of question, you could really have been thrown with this by not being told what you'd be concerned, all of the information. If you're just told the point, you're not told the radius. Take a step back and look at the things you know. So again, with this question, you know that if you brought that out to the generatrix or generator, you could have brought that out perpendicular. That's one line that contains the center point. You know that from over here. And you know that if you bisect to this angle and burn it up, that's another line that the center point falls on. And where those two intersect will be the center point of the sphere you're being asked to find. Again, I'd just like you to pay attention to where the sphere ends up in the plan. So it's in front, so the cone would end up having the piece here. Alright, the hidden detail. The cone would also be hidden detail down here underneath. And there's just little details like that that'll get you marks. Now, I'm going to do another one over here. I'm actually going to cut this video short just so it uploads faster. And I'm going to do another page so we just have more room. And we're going to do, if you're given a sphere, all right, and you're given an angle, so that's the same as this one, if you're told the radius and the angle it sits on. And then if you're told that there's another sphere in contact with both of those. So we'll do that one next.